Well, welcome back tonight. We are finally ready to do some area on the calculator. Now, many times this is a non-calculated question, but several times it is, so we need to be prepared for it. So please don't waste your time. Make sure you have your calculator with you. There's going to be a lot of new buttons, a lot of storing, and we really need to be on top of our game tomorrow. So pause it, go grab that calculator. Question number 1. Find the area bounded by the curves f of x equals x squared minus 1 and g of x equals 3 sine x. Okay, now you don't have to, I know you can sketch them out, but you don't need to do it by hand. We're going to throw them in the calculator. Okay, I'm going to put this one in y1, and I'm going to put this function in y2. Okay, now remember, a few things to check. Make sure you are in radian mode. Once I have them in, I'm immediately hitting zoom 6. That again is my standard window. If you hit the zoom button, you'll see 6 as standard. When I do that, okay, and your graph should look the same, I get this nice graph here. Now, you'll notice I have a lot of wasted space. And first, we should really zone in on the area we're finding. It says find the area bounded by the two curves. And again, if you've got colored pencils or pens, I think if you put them in color, it's extremely obvious what area is bounded by the curves. Okay, there is only one section that I see between those two curves. And hopefully it's obvious that we're looking at this section here. Okay, so basically I'm saying I have all this wasted space. Now it's not necessary to change this, but a lot of times it's helpful to people. So I'm going to cut this out of the picture, and I'm going to cut this out of the picture. All right, so let's practice with our window. Okay, all the graphing features are on the top row. Hit your window button, and let's change our x min and x max. I don't need all this stuff. I'm going to change my x min to, let's say, -3, and I'm going to change my x max to +3. All right, so pause it, do that on your calculator, and then let's compare. All right, so now you can get a better version of that picture. You can see it a little better. You know, we're looking in this section. That's the only place they're going to be bounded together. All right, so we need to put that slice in. We need to determine, does it make more sense to go vertical or horizontal? Okay, and picture that slice going in. If I go vertical, all right, I believe that's only going to give me one slice, which is exactly what I want. This part is not an option. Put that vertical slice in. Okay, and again, I'm going to stick this in color so it's more obvious. All right, and you've got to ask yourself, is my upper always on the green, and is my lower always on the red? And this vertical line can basically slide left, and it can slide right. Okay, as it slides back and forth in here, is the upper always on green, is the lower always on red? If you said yes, which I hope you did, that means we only have one integral to set up our area problem. Now what do we have to get? Well, of course we have to go find the points where these things intersect. Okay, so I need to get this point here, which I'm going to call A. Now again, I'm going to do this once tonight. All right, make sure you're taking good notes and you're practicing along on your own calculator. I need to find where they intersect. So I am going, jot them in your notebook if you're not a pro at this by now. Second trace, intersection. Okay, intersection is number 5. If you hit number 5, all right, and I will show some of my calculator screens here. This is the one time I'm going to do this. So I hit that second trace intersect, and the first thing that should appear is read your calculator screen. At the bottom left, it should say first curve, and in the top left corner, it should say y1. First, y1. They go together. You hit enter and agree. The next thing it should say in the bottom left is second curve. In the top, it should automatically change to y2. Do we agree that 2 and second go together? Hit enter, you agree. It will then ask you to take a guess. You do not need to move your cursor, just hit enter that you agree that's where you're guessing, and it should come up with an exact intersection point. Now notice, my cursor was closest to this intersection point, so it found this one. If you started on your first curve and you were closer to this intersection point, you would have gotten this one. Okay, now here's where the big deal comes in. Clearly, this is my point that I'm going to use. Okay, now this is a hideous number. Okay, we cannot have that rounded number as part of our answer. We have to store. Okay, so let me say it again. You have to store, not an option. Okay, so you do want to store this into alpha A. So let's make a note on our paper. We need to store that point into alpha A. Now here's how you do it. Again, I will show you my calculator screens. Play along with me, make sure you're doing the same thing. So currently, every variable in your calculator has a number stored into it. Whether you knew it or not, we automatically have numbers stored in, and it doesn't affect what we do on a normal basis. So at the moment, when you found this intersection, the calculator automatically stored negative 3.067554 blah 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 into the letter x. Okay, so here's what you have to do. We can't leave it as x. You need to go, and you can put this on paper, you're going to hit second, quit. Okay, second is right here, quit is right next to it. That will take you back to your home screen. You're going to hit the X button, okay, which is right here, and you're going to say store into alpha A. The store button is down here on your calculator. It says STO, and then hit the green alpha button, and A is on the test key or math key. Okay, so you are saying X store into alpha A, and it will now store this number into A for you. Okay, again, you can't leave it in X, you need to store that number. Now we're going to do the same thing. We're going to go get the next intersection point. Okay, so again, I will show all my steps this one time. All right, so I'm going to get the next point of intersection, which is over here. So you're going to hit the same thing. You're going to go back to second trace, choose intersect. Okay, now be smart. Move your cursor over here. It will find the one it's closest to. If you find the same one over and over, you're not getting it. You got to move over to this point and get the one it's closest to. Basically, you're hitting your enter, 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 first curve, second curve, guess, and you should get this 1.946 number. Now again, you have to go second, quit. Okay, it takes you back to the home screen. This number is currently stored into X, so pull X up, and then say store that into alpha B. You need to pick a different letter. We stored this one into A, and this one into B. Now that we have those numbers stored into A and B, we're actually ready to set up our integral. So on paper, I'm going to say the area is equal to the integral from A to B. You do not need to write those decimals out. We just need to say from A to B. And now we have to make sure we pick the right upper minus lower. Let's get that vertical line drawn in again. My upper is on the sine curve, which was 3 sine of x, minus my lower, which is on the parabola, and I'm going to put parentheses in there, which is x squared minus 1. Okay, now notice I'm using the parentheses. Okay, we want to make sure we distribute correctly. Now, since we can use the calculator, all right, I'm typing all of this in, and I want to be clear, in my calculator, this chunk is in my y2, and I'm going to label that underneath, and this chunk is in my y1. Hopefully it's the same in yours. If not, just be careful. And we are literally typing in our calculator the integral from A to B of y2 minus y1. Okay, do not retype these in, they're already stored in. So you can see my setup. I literally did the integral from A to B of y2 minus y1. Okay, now one last time, I know I went through that very, very slow. Hopefully you've got it on your own here. I want to talk about what the AP is looking for. Okay, at some point on your paper, you need to say what A equals and what B equals. Okay, so at some point I need to say that A equals negative point, and you can round it, 307. And that B equals 1.947. And then once you state that once, you are free to use A and B on paper throughout the whole thing. But this has to be stated once. All right, next question. Find the area bounded by these three curves. Okay, now clearly, we have a y equals button. So you can type this equation in and you can type this equation in, but you cannot type this one in. Okay, that's why our sketch on paper is so important. Okay, you're not just taking it for granted on your calculator. We need to sketch it on paper. Okay, so it doesn't need to be totally perfect because it's just a sketch, but let's carefully type this in. Now, if you have the updated calculator, you have the alpha y equals button, which pulls up a fraction tool. However, if you have the Inspire that may not be updated or the old TI-83, I cannot stress enough, the top needs to be in parentheses and the bottom needs to be in parentheses on fractions. Okay, so let's get this function in y1 and this in y2. And then again, we're going to hit zoom 6 and get a nice view of our graph. So quickly, this is what my functions looked like in y1 and y2. And then here's what my graph looked like on my Zoom 6, okay? Zoom 6 is our standard window. Now, I want to stress, I want this on paper, okay? Let's not make this an option. Let's get this graphed, and it's just a quick sketch. Look something like that, and let's throw a different color on here, something like this. Okay, now, the reason we've got to sketch it is because, I don't know if you can tell here, but these two functions don't actually intersect again. Okay, this guy keeps going up, and this guy kind of has this asymptote off to the side. And the reason we have to be careful about that is we haven't actually graphed the third function. Now, you cannot graph this on your calculator. Your calculator, of all it can do, it's not sophisticated enough to graph an x equals equation. Okay, so this is why it needs to be on paper, and we need to graph that ourselves. So I'm going to throw a different color up here, and I'm going to graph the line x equals 3. Okay, so our area is bounded by those three colors, which I hope is obvious at this point. I'm going to go with this section in here. Okay, this section is bounded by those three things. All right, so my next question, or my next piece of information, is to draw my vertical slicing and ask myself, does my upper and lower ever change, or is one integral enough? Is my upper always on the purple and my lower always on the green? Okay, well, that answer is yes, so one integral will be perfect. So I'm going to say area equals the integral. Okay, now let's talk about our bounds. This blue bear here can move to the left and to the right. How far to the left can it go? Well, it can go until these two things intersect. So you need to use your calculator, get that number, and store it into alpha A. How far to the right can it go? Well, it's going to go until it hits x equals 3. So I know automatically my upper bound is 3. So let's take a minute, go pause it, and go get this point of intersection. So you can see my work off to the side. I grabbed the intersection. I got negative 1.334 junk. I did second quit, take x and store it into A. So now it's an A, and you can call it A on your paper, but remember, you have to write that down for the AP grader to read. So I need to say A equals negative 1.334 someplace on paper. Okay, you will not get your 9 out of 9 if we don't have that on paper someplace. And now just be careful, make sure we do upper minus lower. My upper is the purple curve, which is the, what curve was that? That was the ln curve. So I'm going to put a nice bracket, and I'm going to type that ln first, ln of x plus 5 minus the lower, which is the fraction, 3x squared over x squared plus 2x plus 5. Okay, and don't forget your dx on there. And lastly, I'm just going to make a note to myself on where this was typed in. This junk was typed in my y2 minus my y1. Now I just want to be very clear, the AP will not give you credit for writing y2 minus y1. You do need to write the function in there. Alright, so let's go to our calculator, set up that integral, and see what we get. And I've got mine right here. Whoops. I just want to remind you, 3 decimal places, so 5.0, that's going to round that up, 10. Alright. Alright, well hopefully you're thinking this is semi-easy. We're just kind of playing with the calculator, getting points of intersection and integrating on the calculator. We don't have to do too much by hand. Here's where it gets nasty. Alright, so they gave us 3 functions below, and I would pause it, get this function sketched in y1, y2, y3. Arctan is obviously second tan or inverse tan on our calculator. Okay, and then I'm not going to hit Zoom 6 because they gave me this graph to go with it. So you can clearly see that it goes from 0 to 9 and 0 to 11. So hit your window. X min is 0 to 9, Y min 0 to Y max 11. Okay, so what I did is I pulled mine up, so pause it, do what you need to do. I pulled mine up on my calculator here. Whoops. And I think the calculator can be a little misleading, so don't just jump to conclusion. You can clearly see that S is here, T is here, U is here, V is here. The one that's hard to read is R. It's very obvious in their blown up picture, but it's not so obvious in mine. So again, please don't just assume that those are, a straight line. You're always going to have to zoom in and be smart about that. Alright, now I want to change my question here. I don't want to find the area of region T. I want us to focus on the area of region U. Okay, so let's fix the question. Our goal is to find the area of region U. Now, if you've got those colored pencils handy, which I hope you do, I think you should go over your lines in color. It's going to make it much, much more obvious. Alright, so again, my goal is to focus on region U, and I'm going to lightly shade it in just so we're all on the same page here. And my goal is to get this area in here. Okay, so I need to draw in my vertical slice. Notice these all are in terms of the letter X, so I'm going to draw my vertical slice in. Okay, and again, this is not an option. Put these little endpoints on it. Okay, this is going to help us for our volume unit that we do next after this. Okay, now, say to yourself, currently my upper is on green. If I take this slice, I can obviously slide it to the left and right. Okay, is my upper always going to stay on green? Your answer better be no. Okay, as I move this way, my upper now becomes on red. I can draw my other, also draw another slice in. Now my upper's on red. Okay, so that's telling me I have at least two different integrals, and that's why those colors are so helpful. Okay, is my bottom always staying on blue? Yes, but my upper is changing, so I need two separate integrals. Okay, now let's talk about the bounds that we're going to have. This first vertical line, okay, can move left and right. It's going to move left until they meet here, so I need to get this intersection, so let's circle this intersection and label it A. Okay, then it can move to the right until they meet there. So I want you to circle this intersection and let's label it B. Make that nice and bold. Okay, and then they're going to move on this guy and they're going to move right until they meet here, and let's label this intersection C. So you have 3 points of intersection we need to go get. All right, now you're going to have to be careful about which functions you're talking about. So let's first go get the intersection on our calculator at point A, which is the green line and the blue line. All right, now let me warn you, okay? It's going to automatically jump to different curves, and it will tell you at the top what curve you're on. If you're trying to get this point of intersection, and you're on this curve and this curve, clearly, is that going to get you this point? Of course not. So if it first puts you on this curve and you hit enter, okay, and then it automatically takes you to this curve, if you arrow up and down, it will jump from curve to curve. Okay, the up and down buttons will jump from curve to curve, so you might have to move your cursor to the curves that you want. Hopefully these are your A, B, and C values. Once I found each intersection point, I went to my home screen and stored it into A, B, and C. Now I can set up my integral. Okay, so it's going to be a little tricky. I'm going to have to go back and look at my picture. My first upper and lower, okay, is going to go from the bounds A to B. Okay, so my area equals the integral from A to B. Okay, now be careful who your upper and lower is. My upper is that green line, okay, which was the inverse tan graph. So I think that was 5 tan inverse of x plus 3 minus my blue graph, which is my cosine graph, 3 cosine of x plus 3 dx, and put a big plus sign. We have to add on to that. Okay, we now need the next section. This line is going to go from B to C. Okay, I'm going to go from this point to this point. Its upper is on the red curve, which is the x minus 5 squared plus 5, minus its lower is on the blue curve, which is that cosine curve. Okay, now you're going to have to be real careful typing all that in. So if it helps, label your y1, y2s, etc. underneath. Okay, so this was in my y1, this was in my y3. This was in, oops, I lied, that was in my y2. This was in my y3 minus my y2. Okay, we're going to carefully type all that in our calculator. All right, so I got mine typed in. Again, if you've got that old version, I know you've got a million parentheses and you just got to be real careful. The update, you've got this nice integral, I said from A to B, and that's why I label them y1 minus y2 plus B to C, y3 minus y2, and here's the area that I got. Just recall that we're going to round her off to 3 decimal places, and we've got our total area. Well, that's enough practice for tonight. We're going to get a lot of it tomorrow. So good luck, and I'll see you then.